Welcome to Public Health on Call, a podcast from the Johns Hopkins Bloomberg School of Public Health, where we bring evidence, experience, and perspective to make sense of today's leading health challenges. If you have questions or ideas for us, please send an email to publichealthquestion@jhu.edu. That's publichealthquestion@jhu.edu for future podcast episodes.
It's Lindsay Smith Rogers. Today, how a community in a remote part of Colombia has helped advance our understanding of early onset Alzheimer's. I speak with Jennie Erin Smith, author of the book Valley of Forgetting: Alzheimer's Families and the Search for a Cure, about the Paisa mutation discovered in the 1980s among residents living in the mountains, and how a research program built with community members there yielded so much information about this devastating disease. Let's listen. Jennie Erin Smith, thank you so much for joining us on Public Health on Call. Why don't you start out by telling us where you are?
I am right now in Medellín, Colombia, which is the same site of the book that I recently published, and where I spent 7 years looking into issues of early onset Alzheimer's disease.
The book that you're talking about is Valley of Forgetting: Alzheimer's Families and the Search for a Cure. Could you tell us how this story begins?
Lindsay, this is actually a famous story, at least in the Alzheimer's research world, but it's been covered a lot. The story is about a giant family of 6,000 people, many of whom carry a mutation that causes early onset Alzheimer's disease in their 40s. And the family was discovered by a Colombian neurologist in 1984. The neurologist's name was Francisco Lopera. He went on to be quite famous in the United States and later in the Alzheimer's research world in general. He was a young doctor when he sort of came upon this family. He had just finished up his mandatory government service, which is where they send out in Colombia doctors to the sticks and the jungles in their first year after medical school, wanting them to have real world experience.
Like if every doctor in America had to do a year of Peace Corps or AmeriCorps or something before they went into practice.
Yes, in Colombia since the 1960s, and has been replicated in many other Latin American countries, is that either before you graduate medical school or your first year out, you are sent to a very remote and underserved community. It's called the Médico Rural. And at the time when Dr. Lopera was doing his Médico Rural service, or his rural service, he was working in the neurology department as a resident in his local public hospital in Medellín when a man came in who was 49 years old who had really severe advanced dementia. At the time, families with early onset dementia were known to science, but they were not well understood, and they were of great interest because in the 80s, Alzheimer's disease was starting to be understood as the public health crisis that it later emerged as. And so Dr. Lopera kind of got the idea early on that he might be dealing with a hereditary condition. So this gentleman who was 49 years old with severe dementia was a farmer, farming in a mountainside community several hours from Medellín, which was hard to get to. And so what Dr. Lopera did that I thought was unique or was remarkable was set out on sort of a mini expedition for this place and sit with the families and do genealogies and to see if this might be an inherited condition. And he realized fairly quickly that it was. And so that was the beginning. That's what sort of broke open this study that went on to last 40 more years.
He goes out, he starts interviewing these families and putting together this picture of a group of people that have a mutation.
In the end, yes, it took a while to figure out that they did have a mutation. But Dr. Lopera, by doing the genealogical legwork, which nobody else had done, suspected a gene early on. In the 1990s, Dr. Lopera began collaborating with American researchers, a couple who are now famous Alzheimer's researchers. One is a geneticist named Alison Goat. The other is Ken Kosick. He's a cell biologist. Those collaborations were very important at the time because they launched a gene hunt. At the time, there was an understanding that there were a gene or multiple genes responsible for early onset Alzheimer's disease, but they didn't know which ones. And so with a family this big, they knew they had a good shot at establishing the gene with the technology available at the time. The gene turned out to be presenilin 1, which is an important gene in early onset Alzheimer's, and all of these Colombian people with the disease shared a mutation that came to be known as the Paisa mutation, named after the place that they come from in Colombia. It is the largest on an order of magnitude early onset Alzheimer's family in the world. And so that's why it has been of such interest to science.
They found this genetic mutation. They know it has something to do with early onset Alzheimer's, but they maybe don't fully understand the mechanism. And so that's part of what they're going to look at. But then you mentioned that's when clinical trials and drugs start to get involved.
Well, so there was a little bit of a period between like the year 2000 and like, say, 2008, in which Dr. Lopera was studying these families, but there were no drugs to test. So what he was doing actually ended up being very important. When you have a population with mutations that you can test for, you can predict who will get sick. This is a mutation with 100% penetrance. So you're going to get sick. And so he began this long-term natural history study of the disease just to see how it unfolded in people's brains, in people's bodies. I mean, they did all kinds of work with this population so that by around 2008, there started to be an interest in the possibility of preventing Alzheimer's disease with drugs. That possibility was emerging in the Alzheimer's research world. And who better to try it in than people whom you know are guaranteed to become sick. In fact, I heard one researcher phrase it one time as destined to dement. And that phrase just kind of stuck with me, destined to dement. But yes, that was how they looked at it, and that was the truth. And so the idea was to intervene on people while they were still well and see if this drug, in this case, a drug that worked on the protein amyloid beta, which was the first disease protein to appear in Alzheimer's disease, to see if you could keep them from getting sick. 50% of people who are children of someone with this disease will inherit that mutation. So you have a 50% chance of being born with it. The physicians, the researchers in this group, tested people for the mutation. Almost as soon as they discovered it, they were able to test for it. And so from the late 1990s on, people were getting tested for it, but the results were not given to them. That was a peculiarity of the Colombian study, which actually sort of came to become a problem later.
So genetic testing was available. They tested a lot of people. How did they determine who found out and who didn't?
So this is something that I spent a lot of time working on and trying to understand as I wrote this book, because, almost as soon as different tests were developed for neurological mutations that could cause neurodegenerative disease, Huntington's disease, Alzheimer's disease, it was almost immediately made available to the families, but not in Colombia. And part of that, Dr. Lopera sort of explained as we didn't have the money. We didn't have the counseling. You can't just deliver a genetic result like a cholesterol test. I mean, there's a whole process involved in this. And so for years, people were discouraged from seeking that result, told that they might commit suicide, that they might become depressed. And so going into this large clinical trial, right, that got planned starting around 2008, but got off the ground in 2013, you had this unusual circumstance that you're testing drugs in people who don't know whether they need them or not. And everybody who did not have the mutation ended up getting placebo. The ethical concern here is that you're asking them to give up 8 to 10 years of their lives testing a drug that they might not even need. So, yeah, that was a very thorny ethical issue. Thankfully, over time, this sort of ban on telling people has eroded. Dr. Lopera loosened up about it. People have gotten tested and sought their own testing and know they did not commit suicide and know they did not become clinically depressed. So this has loosened up a little bit.
Tell us about the clinical trials. And just to set the scene for all of this, it's taking place in Colombia against the backdrop of a lot of unrest. So lead us into the clinical trial era.
Around 2006, 2007, there started to be interest in clinical trials in people who weren't yet sick right? Members of early onset Alzheimer's families to see if drugs could keep them from getting sick. And the Colombian population was deemed almost the perfect population to test these drugs in because people all had the same mutation. Second, they all shared a similar way of life, a similar diet. And third, and most importantly, this was a humongous family, of thousands of people, of whom several hundred could be selected for a trial. So the complicating factor was, as you just said, Colombia was a mess. Throughout Dr. Lopera's entire career that I've described, he had to go into exile in the 80s when his university was attacked by paramilitaries. People got kidnapped in this research group because they were out in the hills working with the farming families. There were constant dangers. So the recruitment for this clinical trial took place against a backdrop of violence and danger for the families involved and also for the physicians. And it was thought that it couldn't be done, but they did it. And they did it thanks to just so many heroic efforts by so many people.
Tell us how that first iteration of the clinical trials went and how it was received and what they found from that.
So the trial lasted from 2013 to 2022. Alzheimer's drug trials, if you're trying to look for an actual clinical effect, these trials are really long. These patients spent, 8 years being studied. In 2022, the drug, which was called crenezumab, was like an antibody that attacked amyloid protein in the brain and prevented it from building up. It was found that it had failed. Obviously, it was a very sad day, but it wasn't exactly unexpected because anti-amyloid drugs were not doing well in any real clinical trials. And the clinical trials that established their feasibility and were used to get certain anti-amyloid drugs approved, those drugs are still not exactly the answer to Alzheimer's disease. They only slow it a little bit. So to have a result like this in a population that was almost ideal to test in because they were completely disease-free at the beginning of the trial, and to have it fail anyway was heartbreaking. But beyond that, this was a very special population that's often described as a vulnerable population. So, in any person or any family or any circumstance, it's going to be terribly disappointed to have a drug trial fail, right? Especially, for a disease like this. But in this population, it's even more poignant to see that.
There's a quote in your book that I love where you say this is what families had learned over all these years of taking part in this: to resist undue hope and to resist despair.
Yeah.
That is so powerful.
That's Colombia. I will say this, Colombians are tough people. And I was present at the end of the trial, and yes, people cried, but they also danced. There was a party, I think that this population knew what they were doing, and they were ready, unfortunately, for that result.
With these clinical trials that are taking place in this, a remote area that's hard to reach, let's say the drug was successful. Then you've got, how do you've got researchers coming in and doing all these clinical trials, and then they go back to America. What happens then? Are they able to bring those drugs into Colombia to make them available?
That was an issue that was of great interest to me because I could never get any hard answers from anyone, not the drug company, not the sponsors of the trial, not Dr. Lopera himself, about what would happen if the drug were successful. Before this drug trial result, one very similar anti-amyloid drug had been approved in the United States, and it was called Aduhelm, and it was by Biogen. Very similar mechanism of action. The price on that drug in the United States was over $50,000 a year. Later on, they slashed it to something like $30,000 a year. I calculated that for a Colombian person making minimum wage, which 50% of people in Colombia do, and this was a poor population in Colombia that they were doing the trial on, would have to work 18 years to afford a single year of that drug. Now, prices are often set lower in developing countries, but even at $5,000, I didn't believe that there would be any meaningful access to that drug. There might be access to the drug, but I didn't think there would be meaningful access to this drug. This is a problem all over the world where you have drugs being tried in underprivileged populations. A lot of times the companies, like there is an antidepressant that you see ads for it all the time on TV in the United States that was actually tried in Colombia and never marketed in Colombia, right? So that's a concern. And some countries like Brazil have just pushed back and put limits on it, saying that you can't try these drugs here unless you're prepared to give them to people for at least 5 years if they work. Because crenezumab didn't work, we didn't end up having to solve this problem.
When this research first kicks off, who's paying for it?
So in the 1980s, Dr. Lopera was paying for everything by himself. In about 1989, a division of NIH was sponsoring some of the work in Colombia. And over time, NIH's commitment to this particular research group and these trials really increased. So the clinical trial of crenezumab got lots of funding from NIH. An ongoing trial, or a trial that's supposed to get off the ground, has a lot of funding from NIH. And then finally, the brain bank, by which, people in these families donated their loved ones' brains to be studied over like a 30-year period, that in recent years has also had a lot of funding from NIH. So NIH has been very important to this research group. That's part of the question ahead, is what happens when you don't have that grant funding. There's funding in place through 26. And then everything after that, I would say, is a question mark. So the question I have is, these are people who did research without money for many, many years before they had money, right? Can you go back? Is there a way to continue the thread? One of the things that's so remarkable about Dr. Lopera, among the many things that was remarkable about his life, is that he did this on a shoestring. He kept this Alzheimer's cohort together for more than 20 years before he had really serious funding. And so the question is, what can be done without it?
Where are we with drugs, with what we know about the disease, and how did this population contribute to that overall body of scientific knowledge?
Well, this population has contributed a lot to knowledge of Alzheimer's since the 1980s. Genetic studies, a lot of different types of studies, brain studies, because they've donated brains since 1985 or something like that. I mean, really long time. But one of the ways in which a surprise contribution, right, which wasn't directly from the trial, but it was indirectly from the trial, from all the resources that the trial engendered, was the discovery of people who had the mutation but did not get sick, on schedule. They got sick much later, if they got sick at all. And all of a sudden, as the anti-amyloid drugs were starting to look less promising, they were starting to look less like the magic bullet that it was hoped that they would be, there started to be an absolute scramble to study these individuals. And because this family was so large, you're talking 6,000 people, of whom maybe 2,000 at any given time are carriers of the mutation. You could identify at least 7 or 8 cases in this population, which is like more than exists in the whole scientific literature. And so there's been a parallel scramble to understand the mechanisms by which they beat the disease and, of course, potentially replicate them. I'm not particularly pessimistic about the future of Alzheimer's disease research. I'm pessimistic about amyloid-based approaches. I'm pessimistic about the amount of money thrown into that and how it set the field back. But I'm not pessimistic in terms of hope for an ultimate solution to the neurodegenerative process, which is such a devastating process.
The amyloid hypothesis is a through line through the book. That is kind of what researchers were really banking a lot on. This is the thing that is causing it. If we can figure this out, we can stop the disease from progressing. Tell us about, everyone's chasing this one thing, and then when this one thing comes out to fail, you kind of got to change tracks.
I would argue that the Colombians, this population, like so many populations that tested drugs, were on some level a victim of the myopia that affected Alzheimer's disease research for so many years. At the same time, these same Colombian cases back in the 80s and 90s also contributed to the amyloid hypothesis, because the presenilin gene, when there's a mutation on presenilin, the first thing that happens in the brain, they learned from brain studies, is it floods your brain with amyloid beta. So there is a question as to whether or not the whole of Alzheimer's disease follows the same pattern that these early onset cases follow. And that maybe too much obsessive studying of the early onset cases led to some errors about the pathogenesis, in the late onset cases, an over obsession with amyloid beta.
Huge part of your story is about family members who are caring for people with Alzheimer's who themselves may be predisposed. Tell us about your work with the caregivers.
I would say that was my favorite part of reporting this story, was the relationships that I developed with these families. Until I got involved in this, many journalists came down to spend a week, 2 weeks, with the researchers and meet some of the families. I had the chance to see them live with this disease over time. One of the unique characteristics of this population is just because of the population structure, what you had very often was a 20 or 25-year-old young adult caring for a 45 or 50-year-old sick adult. The effects of that on this generation are so profound because it knocks them sideways for work and studies, and it's very difficult to get back on track. And when I went into this story, I expected that I would be very, very moved by the people my own age, because I was 44 at the time, which is the average age of onset of symptoms. I thought I would be very moved by people my own age getting sick. But in the end, this became the story of their kids. I related more to them. They tended to have more education. They were a little more urban than their parents. And they had questions. They had questions for the researchers, and they had questions for themselves. And that's something that I get into very deeply in this book.
Where do you think the research and the story goes next? You've mentioned that you have these outlier cases that now are getting some more attention, but the story kind of ends like right at this moment where one drug trial has failed, the hypotheses are changing, there's some hope for the future. Where are we now?
Well, unfortunately, Dr. Lopera died in September of 2024. He died of cancer, and he died sort of at the height of his fame and powers. There is a director of his research group. They continue to collaborate, including on clinical trials. Some of those clinical trials involve anti-amyloid agents. Some of them are not even to see whether they stop the disease, but just to see what they're doing in the brain. All of that stuff is ongoing. But I do believe that the likely legacy of all this will be the outlier cases and what's done with them. I think that was a real surprise. If it hadn't been for these wonderful outlier cases, and I got to know one personally, one of the most famous ones. I tell her story. She was a wild lady, and I think studying them and really unlocking what it is that stopped them from getting sick is the future.
So the story's not over.
No, I hope not.
Jennie Erin Smith, thank you so much for being with us on Public Health on Call.
Thank you, Lindsay.
Public Health on Call is a podcast from the Johns Hopkins Bloomberg School of Public Health, produced by Joshua Sharfstein, Lindsay Smith Rogers, Stephanie Desmond, and Grace Fernandez-Ciceri. Audio production by J.B. Arbogast, Michael Bonfils, Spencer Greer, Matthew Martin, and Philip Porter, with support from Chip Hickey. Distribution by Nick Moran. Production coordination by Catherine Ricardo. Social media run by Grace Fernandez-Ciceri. Analytics by Elisa Rosen. If you have questions or ideas for us, please send an email to publichealthquestion@jhu.edu. That's publichealthquestion@jhu.edu for future podcast episodes. Thank you for listening.